interactions between the entities involved in a secure relationship. Specifically, the interactions involved in establishing the relationship. First, association ceremony for OOB channel key distribution. Okay, this ceremony is used with the devices that have some means of other than wireless USB for receiving a connection context. You look at this diagram, you will get those things. So user is here. Okay, now host and device. So user distributing CC and user distributing C. Look at here, this is a bidirectional arrow, right? So the host is showing some connection context. From that, user is seeing that connection context from the host, and he is giving that connection context to here. He may type, we can consider in that way, he may type also. Then after that, what's happening? Now both the host and device is having the connection context. Now the host will send that MMC and all. In that case, it will send this connection context. During that particular allotted time, it will send connection context. For that, host has to give acknowledgement. Now the initial connection is over. Next, authentication process. Authentication process will happen through four-way handshake process. This handshake process will happen. Handshake process is protected by using this connection key, but we know that at the end of this four-way handshake, it will derive PTK, pairwise temporal key, that will be used for the remaining operation. Right now, you come back to this slide. So the regardless of how this OOB channel is implemented, some type of user action will be required to either initiate or complete distribution of the connection context to the device. If you look at this diagram, see here the user only transmitting that CC. We know that user interface also a out of band channel. We can say that user interface is also out of band. So the user may either directly enter the context information or physically shuttle context container. Okay. So that's all about the ceremony by using OOB channel. Now we are going to see about the ceremony for association using a fixed symmetric key. Shortly we can say FSK. Okay. Now this ceremony is used for devices that contain a static symmetrical key for association purpose. Here the static indicates that, because static indicates that is a fixed one. Fixed in the sense that it is an odd wired, right? In previous slide we have seen that fixed symmetric key is an odd wired one. That is why. And this key must uniquely represent the device. We know that each device will have its own FSK. This key can be created during the manufacturing, or in some cases be created by device when the first powered up. During the first powered up time, it may create a random number that will become fixed symmetric key for that device. So the key must exist when the device attempts to associate. So this is a diagram regarding that ceremony for fixed FSK, fixed symmetric key. Look at here what's happening. We know that in the device side we will have that hardwired key. Okay, so the user seeing that key first, then he is entering that FSK, fixed symmetric key in host. We can consider it as a in host